The first thing to review in connection with mixtures of gases, vapors, and liquids are a couple of concepts. First of all, what do we mean by fractions involved with mixtures? And also, what do we mean by when we talk about partial quantities? So let's explain these, because these terms are going to be used quite a bit in our subsequent discussion. And the first thing is, let's imagine that we had a mass which is a mixture of various gases, and there'll be a certain amount of gas A and a certain amount of gas B. Of course, they'll all be mixed together, so I'm showing them separately right now. And there'll be some of gas C, and they're all mixed together to form some mixture called D. So let's say D is the total. Then we would take the ratio of A to D and say that represents the mass fraction. There'll be a mass fraction. And similarly, the ratio of B to D would be the mass fraction of B, and similarly C divided by D is the mass fraction of C. Now symbolically, we write this as a W and with a little I subscript, and this really means the ratio of m sub I over the total mass of the mixture. So this gives us an idea what we mean by a mass fraction. And very often we will assume that the total mass is equal to 1. And if that's 1 or unity, then this is usually some number like 0.7 or 0.6 or 0.2 and represents the mass fraction. Now we can see that the total mass, m, is the sum of all the m sub i's that make it up. In other words, D is equal to A plus B plus C. And that the sum of all these m sub i's will add up to give us unity if we normalize everything and speak of the total mass as being equal to 1 unit. So this is what we mean by a mass fraction. This will be repeated time and again. Now the same discussion will hold when we talk about moles. Now when dealing with moles, we will indicate that we have, again, as an example, 3 different components, and let's say A, B, and C add together to give us a total of D units, and that would be the total number of moles of all substances in the mixture. Then we would write that the X sub I, is the symbol we use, would be the ratio of that component to the total number of moles. So we're dealing now with moles, and this becomes a mole fraction. The total N is the sum of the individual components. D is equal to A plus B plus C. And again, we'll assume that the summation of all the X sub I is equal to 1. That these fractions, this may be 0.7, this may be 0.2, and this may be by 0.1, and they add to give you unity. So we'll speak of a mole fraction from this point of view. And we'll use a symbol X sub I to indicate the mole fraction of the ith component. Now, this discussion usually involves dealing with liquids. When we talk about gas instead of a liquid, we usually will talk about the mole fraction and use a different symbol. So while we use X for liquids, when we start talking about gases in its place, let me just erase this and write the word gases in here. We'll just usually use a Y sub I to indicate the mole fraction of a gas. And the summation of the Y sub I, the Y sub I would be the mole fraction of a gas. Yes, I had it right. And the summation of Y sub I is equal to 1. So if we're in the gas phase, we usually use a symbol Y sub I.